This new parent function is actually the inverse of a previously learned exponential function. For example, if we had a function f of x equals 2 to the x, our inverse of that particular graph would be this graph that we have here. That can be really useful, especially if you know how to graph this function. You could pick points on it, reverse the x and y values, and come up with the points on this inverse logarithmic function. One thing to note on this parent function is that this 1, 0 point shows up on every logarithmic parent function regardless of the base. So this would be if there's no transformations on that function, that 0.10 will be there regardless. Now the base will make the other 2 points change slightly. Notice that if our base is 2, we have the 0.21 and the 0.1/2, -1. If this base was 3, we would have the 0.31 and the 0.1/3, -1. So the points that are changing based on the base to the logarithm are those two values, this 2 and this 2, and that will change to whatever the base is for that logarithm. So what we're going to do next is perform some transformations on this parent function. We've done transformations before, and this is the exact same thing. We're just going to now do it with this new parent function and these new points. Another thing that I need to say before we move to that is, very similarly to our exponential function, getting really close to the x-axis, when we have the inverse, we now have the opposite of that. So this is going to get really close to the y-axis, but never actually cross it. This does look like it does touch it here, but that's actually not the case. If you could zoom in on that graph, it would not actually be touching the y-axis. Okay, so now let's take this and do a couple different transformations here. The first one that we have here is log base 2 of x plus 2. Now this plus 2, notice, is inside parentheses. So that means it's going to be inside the function. Inside does the opposite. So if you think about this moving to the right 2, it's actually going to do the opposite, which is going to move to the left 2. So inside opposite of what you think. All right, now let's bring these points on the parent function down here, and I'm just going to plot this as the parent function first, just with a dotted line. So our points that we have up there for our parent function was 1, 0, 2, 1, and 1/2, -1. So this is going to be our parent function, and again, I'm just going to plot this with a dotted line, and it will go off to the right. Now, what I want to do now is move each of these points left 2. So this is going to be, and be careful, this is a half. So we're moving this left 2. So 1, 2. So there's our new point. This one over left 2, and this one over left 2. And now we can draw our new graph. Now, I do want to make a point here that this asymptote here, this line that gets really close to but never crosses, actually moves left 2 as well. So you could actually draw that line, and then you can fill out this part of the graph, and it gets really close to it but never crosses. So what you want to make sure is that this is not going to cross over. You don't graph it that direction. It does, when this moves over 2, that line moves over 2 as well. All right, now let's look at this next one. We have a -4, but it's not in parentheses. It's just hanging out on the outside. So we can move this one down 4. So what I want to do again is graph my parent function. I've got the points. One thing I need to note here, these little values, just pretend that each one of these boxes, each one of these units is just one. This was just poor. When this got pulled in, it had the wrong values on it. So let's just pretend that, you know, this is -1, -2, and so forth. I mean, not -1. What am I saying? 1, 2, and so forth. I was thinking negatives with that. Okay. So parent function again. 1, 0, 2, 1, 1/2, -1. Again, getting really, really close to this, but not crossing. And then this is going to shoot off to the right. Okay. So now moving each of these points down 4. The point I want to make with this one is that this line it gets really, really close to, if I'm just moving this down, that line never moves. So moving this function up and down is not going to change where this line goes. Moving this function left and right requires you to move that asymptote with it. Okay. All right, so let's move this down 4. So now we're going down 4. 1, 2, 3, 4. Down 4 again. 1, 2, 3, 4. And down 4 again. 1, 2, 3, and 4. And now we're going to draw the same graph. And it's going to get really close and not touch it. Okay, so notice that when this just moves down, that line did not move. Obviously, it's just going to get really, really close to it, but 4 units further down. That's it. Okay, so that was graphing a logarithmic function with transformations.